Thanks for introduction, Irene. So I will talk about mobile interface and fabrication, including a Fabnavi system introduced by Irene. So first of all, I'm introducing myself. So who am I? My name is KojiTsukada. Now I'm working as Associate Professor of Future University Hakodate. It's a public university in Hokkaido, that's North Island in Japan. So I will introduce later. So here is the Future University Hakodate. It is a building of the university, and here is the inside of it. So I am basically a researcher of human-computer interaction and ubiquitous computing, and I'm also teaching research on the prototyping and electric circuits and physical components. So I really am interested in the last talk. So I'm also in my research is basically I'm a nature-born inventor, so I like creating anything, and I also living as a maker, so I introduce some projects as a maker. My most famous project is in this picture called Speech Jammer. That won an Ig Nobel Prize at 2012. So I will introduce the later. First, I briefly introduce where is Hakodate. So, do you know here is Tokyo placed in the center, very center of Japan. First of all, Japan has 4 islands. So this is main island and North Island, and 2 South and West Islands. So, and Hakodate is here. The most south part in the North Island, so it's about 700 kilometers. It's a little bit far. So in Taipei, the distance from Taipei and Tokyo is 2,100 meters. So anyway, we live in different islands of Tokyo. So I will. About other makers, so I wrote Make Japan articles, so Japanese version of Make magazine, some articles in its very early stage. So first one is volume 3 at 2007. It focused on creating time-size cameras, so it means taking a picture at the same time with maybe 9 or 10 cameras. So. And the second one is 2008, the Make Japanese Magazine Volume 5. So the article explains how to create chameleon pendant. That means the pendant equipped in the color sensor and 2 color LEDs. So, and the pendant will be changed. The color of the pendant will be changed according to your clothes. So I introduce topic of the day. So first, I will introduce some of my inventions, my research projects. So the second topic is introduce Fabnavi. It's a support system to assemble physical objects using visual instruction. The third topic is time permitting. So I will introduce prototyping lectures and prototyping environment in my university. So the first topic is introduce some of my inventions. So anyway, I start. So first of all, I will introduce speech jammer system. So the system, okay, I will show the video. Oh, sorry. Are you irritated by empty talks at office? Or boring and endless lectures? Speech jammer can solve these problems. When you point a target and pull the trigger, the system detects the target's speech by the directional mic and sends back it at several hundred milliseconds delay with the directional speaker. The speech jammer disturbs the target's speech using delayed auditory feedback. This is the first example in the lab. second example in the lecture.
まず有意警告と有意差というものがあります。有意差というのは 1% から 5%。それに対して有意警告というのは 75%。それで、効果が
So this has been German system. So I briefly introduce what's happened. My hypothesis is here. So first, we assume that when you speak in usual, the animation sorry. When you speak in usual, you unconsciously hear your own voice, and the brain confirms, the speech function works properly. I can speak properly here. And the brain, here, this is a good state. However, when you hear your own voice with slight delay, your brain might become confused and try to modify speech. In result, you might come to stutter or speak slowly. So, with this project, I won the Ig Nobel Prize according to 2012. Do you know the Ig Nobel Prize? Who knows the Ig Nobel Prize? Oh, it's quite small number. Okay. But if I start to introduce Ig Nobel Prize, sorry, you can explain so briefly. Okay, so I'm sorry, I cannot have enough time to explain it in detail. So actually, Ig Nobel Prize is quite famous in Japan or United States. So I have focused on the national television or this article is and become top article in science magazines or of course I'm shown on the Wikipedia. And also. And the speech German also featured in Doraemon. About maybe it's also famous in Taiwan. So it's a Nobita. Is it called also Nobita in Taiwan? I'm not sure. Yeah, he used the speech German system to his mother and say, I can disturb scolding mama. Okay, I will go to next topic. So. The next topic is augmented commodities. So this is my main research topic. Augmented commodities is daily commodities that are augmented with computers and sensors. So they include furniture, everyday goods, and tableware. More typically, we have installed computers into closet, storage boxes, lunch boxes, and alarm clocks and other commodities. So the point of the augmented commodities is that it can support daily activities of users without disturbance using existing context or usage of these commodities. So the challenge of our research is how can augmented commodities change our lives? By exploring through invention, prototyping, and evaluation. So actually I have created so many projects, but since I have very limited time, so I will only explain selected projects. So, okay, the first project is Tagtans. The Tagtans is a novel capture and annotation system that can easily capture pictures of clothes and add annotations to support creating picture database of clothes. So the picture of the Tagtans is here. The system is installed on both doors, and when you hang your clothes, the system automatically captures the picture of clothes and add annotations. So I will show the video of the Tagtans. use the RFID tag on the hanger and the camera on the door and the hook sensor on the other door. Here's a message. The system has also a camera on the outside of the door, so you can easily take your picture of your home coordinates. So here is the example pictures taken by Titans. The top line is innerwear, like t-shirts or something. The second line is outerwear, including coat or jacket. The third line shows bottom wear, mainly in skirt. So we have installed these Titans in actual homes in this not commonly shown the closets. So here is a picture of the Titan system. It's a display and lamps and camera, and the other door equips the hook sensor. And here is the inside components of the door. So we have developed this white component using 3D printer to fix display component of camera, and we have also developed our own components to fix sensors and to fix many sensors. So next project is a pot pet. Pot pet is flower pot type robot which acts autonomously like pets. So it can react to sunlight, water, and people. For example, it's moving to a sunny place automatically. So I show the video of the pot pet. It has multiple sensors, for example, light sensor or humidity sensor or a distance sensor. I like this, the reaction of the cat. See, so again. Here is the function of finding sunlight. So it usually moves around, and when it finds sunlight, it suddenly stops and waits still enough time. When pot pet requires water, it quickly moves around to attract the user's attention. So it's a problem, so it's a little difficult to but it's a success, and it turns around here and show it. I enjoy it. Okay. So the next project is called eTellMe. This device is an interactive fork with audio feedback. So the main aim is amuse meal activities with very simple device. Actually, I have the real one here, so first I will show you real demo. I hope it works. It's not working. Okay. Later I will fix it, so I'm sorry. First I will show you video. This video includes two versions of this eTellMe. First is for eating something, and the second is for drinking something. So this is a fork type device, and this is a cup type device. It's basically a very simple system. There are 2 electrodes on the fork and 2 electrodes on the cup. So when you eat or drink something, and it's very sounds, the vegetable, it's such a
Thank you very much. Wow, so amazing.
That guy is Chinese. Maybe I can show you the real demo. Maybe I can fix it later. So this is the last one I show here. So the point one sensing for project. So the system attach many sensors to a quite tiny fork. So the fork also can communicate with smartphone apps, a smartphone, and you can use applications on the smartphone. So the focus of the system is to detect eating actions, improving eating behavior. So this is a joint work with National Taiwan University, and here is the developer, and Kerry is here. So I will show you only the point of this system. So when you eat something, the panda also eat the same kind of food. So the video is a little bit long, so I will only show the point. When you start the system, the panda will be shown on the display. And since I'm very hungry, so maybe the sound is a little bit unseen. You eat a different color of food. The panda has a different bamboo, and you can get the bamboo point. If you stop eating, the panda starts crying and ask her to eat again. So, maybe I take so long time, but I change the topic to next topic to the Fabnavi system. So this is a support system to assemble physical objects using visual instructions. So we are the team. So I'm the coach, and the second person, the cater, is here. Near the cater is a both university professor, and the third guy. Unfortunately, he is absent today, but he worked at Modular. Do you know Modular? Modular is mainly famous in the Firefox browser, so mainly browser company. So he is only one researcher in Modular person. Maybe he's very talented and very busy. Actually, I have a supported guy. He is here, Ken Teramoto. He's just third year student, undergraduate student, but yeah, very promising programmer. So, maybe most of you know this topic, but I introduced the background. So, here is the Fab edge. So we use the Fab in two meanings. So first one is personal fabrication. That means spread of low cost and business spec digital massing tools like 3D printer and laser cutter. The second meaning is social fabrication. Maybe it's more important than personal. So it means there are many places to share these tools in public space, like here, exactly here. Moreover, there are many services to share data for the digital massing tools on the web. Maybe this Thingiverse is the most famous one, but there are so many types of web services. But even in this coverage, there are remaining problems. So I think it is you can easily duplicate physical parts through personal and social file. For example, you can easily download the data of Lego block from the Thingiverse and print it using 3D printer. It's quite easy way. However, assembling these blocks is still troublesome, especially for creating complicated items, like this building and bridge. So our Fabnavi system focused to design new visual instruction to assemble physical projects, especially in remote places. Our system helps record the assembly process easily and share these instructions on the web and replay them on the remote tabletop. So I will show a small video. It's quite like image video, but anyway, I will show this video, we developed Lego block. So, I explain the system of the Fabnavi very briefly. So, it's basically a pair of camera and projector set above the tabletop. Here is one example of the Fabnavi system. So, we discussed with Kim-san to set it to the Fabcafe's lab over there with these versions. So we also use trigger mechanism for interaction. So you can both use keypad or hit switch or gesture inputs. So and all data stored on the web service. So the Fabnavi feature is less dependent on language and knowledge and skills. So basically, you can assemble objects just by following the visual instruction shown on the table. And I think possibly this approach suited for universal and worldwide use. So in this Lego example, first you align all parts to the desk and select tired parts and assemble the parts. So and continue to use these cycles. So the goal of the Fabnavi is to create a framework for recording and sharing instruction among the world. So the components are not, of course, limited to Lego. For example, we have already tested creating accurate papercraft, or accurate means a lampshade. Maybe also here, over there, that's it. and Lego or origami. So I want to install the Fabnavi system to many Fab labs in the world. So we want to share the instruction in new way and all over the world. Fabnavi, here is the Fabnavi history. So we started the Fabnavi project last year and have exhibition and workshop 5 times. So the last December, I had the workshop at Fabcafe Tokyo, and this March we have the workshop at Fabcafe Taipei just here. So here's a picture of the workshop at Tokyo, and actually they also created the IQ light, the lampshade. And here is the parents and the child. Maybe he takes a lot time to create the parents, and she is very good at creating. Actually, she is the staff of Fabcafe Tokyo. And this parent and child are also good at creating it. She looks so young, but she can create so good. Here's the pictures of the workshop at the Taipei, Fabcafe Taipei. Oh, the location will be changed. But basically, they can also create accurate with almost same instructions, and both in Tokyo and Taipei. Of course, there are little trouble, but basically they can succeed to create accurate. And one accurate is here. By the way, I have time yet? Okay. So I will introduce the final topic very briefly. So I have lectures of prototyping and fabrications on university. So basically, I will introduce. My goal is to develop interactive devices. So it means it includes both electronics and programming function. For example, using Arduino, and structure function using laser cutter 3D printers. So I have some courses, especially for beginners, how to start prototyping interactive devices and working interactive devices. So I have courses in 3 universities. So okay, so I will show you some examples. Some works that are created by the students in these lectures. So, the first one is memory training robot. This is a sketch the students draw. The cursor is not working. So the function C described is you first remember the writing patterns on the robot, and here is she draws 3 lamps on the chest of the robot, and push buttons in same sequences. And she also wants to generate sounds with writing, and he also wants to move hands of the robot in response to which is correct or which is fair. Then I decide the required parts here. So first we created the electronics part. This is the first prototype of the training robot. It includes just electronics parts. And here is the video. Very simple video. So it's succeed version. When you failed, this is just first prototype. It's not looks well, but anyway, it works. But the important, this is the final prototype, and she creates the case using the laser cutter with acrylic board. It looks more and better, much better. So I'll show you the short video with this road. The function is basically the same, but the impression is completely different. The students who create this has no skills to create electronics or structure like this case before she obtained this course. And the course is just 40 times, it's not so many times. So here's another works that I will skip to introduce and design. So this is final topic. So I have a 1-year course this year, and the topic is to make Fabnavi or cafe in the Fabnavi. So just now, here's my proposals. So in spring, we want to educate a student toward Fab Masters. That means learn and share Fab technologies and divided into 4 groups. In summer, we have experience at summer festivals in Fabnavi, and this autumn we want to launch Fabnavi or cafe in Fabnavi. So this is 4 Fab groups in this project, in this course. So 3D Fab means creating 3D objects using 3D CAD or scanner and printers. 2D Fab means creating 3D object by using drawing applications like Illustrator and use a laser cutter or paper cutters. The third one is creating electronic components. So using electronic CAD and CNC milling machine for focus on creating electronic board. The fourth group is creating craft, and that includes hand sewing or CNC sewing tools. I will explain. It's not so important. This is an explanation CD group, but I think most of you are familiar with these things, so I skip it. Here is explanation of 3D fabric groups, but it's also, I think, familiar with you, so I also skip it. I will add little explanation to electronics group. So first, when you want to create your own circuit, first you design the circuit using electronic CAD. Maybe the E-group, Microsoft E is most major software. And the second topic is when you create the data, CAD data, you can create your own board using CNC milling machine. And you can also attach the electronic components using reflow oven. So I have created I have hacked the commercial oven. It's a very cheap oven, and I open it and attach the lights and hack it. So here is the last one, and the craft group. It's including handcraft, sewing, carving, resin coating, and some kind of CNC tools for craft. We have only CNC swing tools, but maybe there are many candidates. Okay. So here's the 60 members in 4 groups: 3D Fab and 2D Fab, the electronics, and crafts. So I want to share technologies through groups and what include through documentation and the workshops. Here, in summer, we have several exhibitions in Hakodate. Here is the open campus. This is the open campus in the last year. So we have small version of Fabcafe, just one day, and we use laser cutter to carve on the cookie and serve it to the customers. Here's another summer exhibition. It's an international science festival in Hakodate, and we will invite Hiroya-san, who is the president of FabLab Japan, and who writes the Fab Life. I show the Chinese version here. So maybe you feel Hakodate is too far from here, but I find here is a direct flight to Taipei to Hakodate, so maybe it's not so far. So if you want, so contact me, so I will introduce many things. Because I often visit Tokyo, but please come to Hakodate. So we are waiting for you with sashimi and sushi and me. Thank you and 谢谢。